What decides whether your video call stays crystal clear while someone else on the same cell is throttled? In 5G, that decision lives in one network function, the Policy Control Function or PCF. Think of the PCF as the traffic cop of the 5G core. It does not carry your packets, it writes the rules that other functions enforce. In this session, we work straight from the core diagrams. For every topic, you get a straightforward example, a harder twist, a classic mistake flag, a short recipe you can copy onto a note card, and a practice prompt. Stay with me. By the end, you will be able to walk an exam question from input through the PCF all the way to the radio and the user plane. First, the three jobs the source assigns to the PCF. Read them like an exam stem. Job 1, support a unified policy framework that governs network behavior. One brain, one set of rules for the whole core. Job 2, provide policy rules to control plane functions so they can enforce them. The PCF decides, AMF, SMF, and friends carry out the decision. Job 3, access subscription information relevant for policy decisions in a unified data repository, the UDR. Here is the method recipe for any diagram that highlights the PCF. 1. Locate the PCF box. 2. Read the function text next to it. 3. List the three jobs in your own words. Unified framework, push rules for enforcement, pull subscription data from UDR. If you skip job 3, you will invent generic policies that ignore what the subscriber actually bought. Before more problems, lock the big topology from the first source slide. Left side, the UE talks to the G node B over the radio. The G node B reaches the AMF on N2 for control and the UPF on N3 for user plane. The AMF anchors mobility. The SMF owns sessions and steers the UPF on N4. Now the policy cluster. PCF sits with a dashed highlight on the slide because it is our focus. It faces the SMF on N7 and the AMF on N15. Nearby sit UDM, AUSF, and NSS for subscription, authentication, and slice selection. They are neighbors, not substitutes for the PCF. Recipe for any core diagram. Find radio, find control plane, find user plane, then circle the PCF and only the interfaces that touch it. That stops you from inventing links that are not on the figure. Straightforward example. Open the diagram labeled Input Sources for PCC Decisions. The PCF sits in the center. Around it, 7 neighbors feed decisions. A F on N5, application influence, like a video app asking for better treatment. NEF on N30, exposure of network capabilities to outside apps. UDR on N36, subscription and policy data. NWDAF on its analytics interface, load and behavior insights. SMF on N7, session context going both ways. AMF on N15, mobility and access context. CHF on N28, charging correlation. Recipe. Start at each neighbor, name the interface, and say what kind of fact it contributes. Do not memorize the N numbers alone. Attach a meaning to every link. Harder variant. Trace a personalized policy. Subscriber gold tier video, cell congested. UDR tells the PCF the plan allows premium video. NWDAF reports the cell is busy. AF requests a low latency slice for the app. CHF confirms charging can meter the boost. Only then does the PCF mint a PCC rule. Classic mistake, building the rule without UDR. You might give every user the boost or nobody. Either way, you break the offer the subscriber paid for. Wrong path output, a beautiful QoS rule that is commercially illegal. Right path, UDR first, then analytics and app input, then decide. Recipe: 1. Gather subscription from UDR. 2. Fold in analytics, app, and charging. 3. Only then emit PCC rules toward the SMF. Practice. Pause and answer in your head. List three key inputs to the PCF and the type of information each provides. Compressed solution. 1. UDR, subscription and stored policy data. 2. AF or NEF, application or exposure requests that influence treatment. 3. AMF or SMF, access, mobility, or session context the decision must fit. Bonus if you named CHF for charging or NWDAF for analytics. If you only listed interface numbers with no data type, rewrite the answer. Examiners want the meaning. Topic 2, distribution. Straightforward example from distribution of session policies. The PCF does not talk to the radio or the user plane directly for session rules. It sends PCC rules, policy and charging control rules, to the SMF on interface N7. A PCC rule is a package, which traffic, what QoS, how to charge, and related controls. The SMF is the session owner, so it is the right place to receive that package. Recipe 1. Find the PCF. 2. Follow the outgoing policy arrow labeled PCC rules. 3. Land on the SMF via N7. If your answer skips the SMF and draws a line from PCF straight to the G node B, you have the wrong hop. Harder variant, the full enforcement chain. PCF creates PCC rules and pushes them on N7 to the SMF. The SMF translates. Toward the UPF, it installs session enforcement pieces often shown as SOR or related templates and forwarding rules on N4. Toward the radio path, QoS rules and profiles reach the G node B through the AMF on N2, with SMF and AMF coordinated on N11. Why the middleman? The SMF holds session context the PCF should not micromanage on every bearer update. Classic mistake, saying the PCF sends QoS rules straight to the G node B. Wrong path, a phantom N interface that does not exist on the source slide. Right path, PCF to SMF, then split to UPF and to G node B via AMF. Recipe, generate at PCF, receive and contextualize at SMF. Emit enforcement to UPF and radio. Practice. Describe the path of a QoS rule from its origin to the G node B. Think it through. Compressed solution. Origin, PCF decides policy and forms PCC rules. Next hop, SMF on N7 receives those rules and derives radio-facing QoS information. Coordination, SMF works with AMF on N11. Last hop, AMF signals the G node B on N2, so the radio applies the QoS. If your answer was PCF direct to G node B, mark it wrong and rewrite the 4-hop story. Topic 3, associations. The bottom diagram shows two children under the PCF. First, the AM Policy Association, created at 5G registration, linking PCF with the AMF. This covers access and mobility-related policy while the UE is registered. Second, the SM Policy Association, created at PDU session establishment, linking PCF with the SMF. This covers per-session QoS and charging policy. Recipe. 1. Identify the two associations. 2. Name the partner NF, AMF, or SMF. 3. State the trigger event, registration versus PDU session establishment. Mixing the triggers is the fastest way to lose marks. Harder variant, glue associations to procedures. When a UE registers, signaling hits the AMF. The AMF may establish an AM policy association toward the PCF so access and mobility policies bind for that registration. Later, when the UE asks for a PDU session, the AMF selects an SMF, and the SMF establishes an SM policy association on N7 to fetch session PCC rules before user plane goes live. Why two associations? Registration policy is not the same object as per session policy. You can be registered with AM policy yet have several sessions, each with its own SM policy. Classic mistake, assuming one association at attach covers every future session. Wrong path, no N7 exchange at session setup, and the UPF runs without fresh PCC rules. Recipe, event fires, partner NF opens the matching association. PCF returns the policy for that scope. Practice. What event leads to the SM policy association being created? Compressed solution. PDU session establishment. Not registration. Registration drives the AM policy association with the AMF. Session establishment drives the SM policy association with the SMF so PCC rules can be applied to that session. Write both triggers side by side on your note card so they never swap under exam pressure. Worked example, end-to-end, real world. A subscriber opens a cloud gaming session on a busy train. Step 1, the UE is already registered, so an AM policy association may already exist between AMF and PCF. Step 2, PDU session establishment begins. SMF creates the SM policy association on N7. Step 3, PCF pulls the gaming tier from UDR, hears congestion from NWDAF, and may take an AF hint for low latency. Step 4, PCF returns PCC rules to the SMF. Step 5, SMF programs the UPF and, with the AMF, pushes QoS toward the G node B. Classic fork. Students stop after step 4 and forget radio and user plane enforcement. Incomplete answer. Say the full chain out loud every time. Associate, decide, distribute, enforce. Interface drill. The numbers examiners love. N5. AF to PCF. Application influence. N7. SMF to PCF. Session policy and PCC rules. N15. AMF to PCF. Access and mobility policy. N28. CHF to PCF. Charging correlation. N30. NEF to PCF. Northbound exposure. N36, UDR to PCF, subscription data. On the enforcement side, after the SMF, N4 toward UPF, N11 between SMF and AMF, N2 from AMF to G node B. Mistake flag, swapping N7 and N15. If you send session PCC rules on N15, you aimed at the wrong partner. Recipe, write 3 columns, interface, endpoints, payload purpose, and fill them from the input and distribution diagrams before you memorize. Last board before the final chant. Exam traps in one place. Trap 1, treating the PCF as a user plane box. It does not forward packets, UPF does. Trap 2, skipping UDR on personalized QoS. Trap 3, drawing PCF straight to G node B for QoS. Trap 4, merging AM and SM associations into one forever link at registration. Trap 5, listing N numbers with no meaning attached. For each trap, write the repair beside it. Control plane only, UDR first, SMF middleman. 2 triggers, 2 associations, interface plus payload. If your practice answer trips any trap, rewrite before you move on. You are ready for the rapid-fire close next. Rapid-fire review of every recipe, in order. Functions. Locate PCF. Read the 3 jobs. Unified framework. Provide rules to control plane. Access UDR subscription data. Inputs. From each neighbor, name the interface and the data type. Never skip UDR on personalized policy. Distribution, PCC rules on N7 to SMF only. SMF then splits enforcement to UPF and, via AMF, to the G node B. Associations, AM with AMF at registration. SM with SMF at PDU session establishment. If you can chant those 4 recipes, you can redraw every slide in this source from memory. You have got this. Walk into the exam, find the PCF, and run the chain.